Hey, Algebra 2. Today we're going to discuss Chapter 2.8, and it is called Absolute Value Functions. So to tie in absolute value functions to piecewise functions, here's one way to define an absolute value. So the absolute value of x, it equals just itself, x, if x is positive, right? Because you know the absolute value of 5 is just 5. Or it's going to equal 0 if x is 0, because the absolute value of 0 is 0. Or it's going to equal the opposite of itself if x is less than 0. So if x, let's say it's the absolute value of -3, then that's just going to equal 3, which is a negative 3. So because of this, you can look here. So the line x is going to be this line right here. The point 0 we got right there, and the line -x is this line over here. So really, it is a piecewise function with these three parts. Now, what you need to notice though is that this graphs a V, okay? And these will always graph a V, and because they're functions, they're going to open either up or down. And they're going to have a vertex point right there. That's your turning point, is your vertex. And so we are going to talk about vertex form for an absolute value function. So this is vertex form. Y equals A times the absolute value of x minus h plus k. So what we need to know is that your vertex, since this is called vertex form, is the point hk. Notice there's this minus sign, right? So if it actually says x minus 3, h is a positive 3 because that minus sign goes in the problem. But if it says absolute value of x plus 3, then h is a negative 3 because you had to have written x minus a negative 3. And then that is your h. Okay, so the h is inside the absolute values, and the k then is at the end, so plus k. So if k is positive, it's obviously positive. If k is negative, or it says minus k, then k is negative. Then there's this a in the front, and this a is actually going to tell you a couple of things. So first of all, if a is greater than 0, then your v is going to open up. If a is less than 0 or negative, your v is going to open down. Okay, that's the first thing it needs to tell you. But the other thing it's going to tell you is the actual slope of your two branches, your two parts of your v's. They're actually the rays. Now, it's kind of like the absolute value of the slope, because one side would have like a positive slope and the other side would have a negative slope, but they're both going to have the same absolute value. So let's take a look at some examples. So we want to graph y equals negative times the absolute value of x minus 1 plus 1. And I forgot to put in a coordinate plane, so we're just going to go with it here. Let me draw in my coordinate plane. Get me some tick marks on here. So the first thing you need to be identifying is the vertex. So 1, 1 there. That is your h and your k. Notice the minus sign's in there. So my vertex is 1, 1. So we're going to put a point at 1, 1. Okay. The next thing I want to know, does this open up or down? So because that's negative, it opens down. Okay. And the next thing I want to know is what is the slope of the sides? Oh, I had a problem saying that for some reason. What is the slope of the sides? So the slope is just going to, well, you could say -1 or you could say 1. So what this means is from my purple vertex here, I'm going to go down 1, right 1, down 1, right 1, and there is that branch. And I'm also going to go down 1, left 1, down 1, left 1. So they both have slopes of 1, even though one side has a positive slope and one side has a negative slope. There's our graph. That's it. So find your vertex. Does it open up or down? And then what is the slope? So here let's look at another one. So I'll get my coordinate plane. Okay. So what's my vertex? Well, that negative sign goes there, so my vertex is 2, -3. That's my h and my k. So my vertex is 2, -3. So I'm going to go to 2 down to -3 and put a point. Now, because it's a positive number, I mean, it's not negative, so it has to be positive, right? This is going to open up, and it's going to have a slope of 1, because really there's a 1. I could put a 1 there. So from my purple point, we're going to go up 1, right 1, up 1, right 1, and there's one branch, and then up 1, left 1, up 1, left 1, and there is the other branch. Next thing we're going to look at is just, can you then write the equation? So from your form, y equals a times the absolute value of x minus h plus k, can we just fill in a, h, and k? So you have to know your vertex. So if we look here, your vertex is 1, 3. So that's h and k. And then you need to know the slope of the sides. And it doesn't necessarily matter if you say positive or negative, but I'm going to say the slope is 2. Because from right here, I can go up 2 and over 1, right? Up 2 and over 1. So the slope is 2, but then I also want that a is negative, and that will make it open down. So my equation is going to be y equals a -2 absolute value of x minus 1 plus 3. There we go. All right, so the other one here, let's get our vertex. Our vertex is -2, -3. And then let's get our slope. I believe our slope is still 2, so we're going to go up 2 and over 1. And then a for this one is positive, right, because we're opening up. So our equation is going to be y equals 2, absolute value of x plus 2 minus 3. And that x plus 2 on the inside is because you're doing minus and negative. Alright, well there's a start to the wonderful world of absolute value functions. Let me know if you have questions. We'll do a couple more examples in class, and have a great day.